Okay, so hopefully you watched the first video, and that means you've completed the first 2 steps in your packet. That would be the goal. So you are now going to be completing assessment number 2 practice, and I do want you to do this independently. Please remember, guys, our goal is not just to get our work done and get the points. The goal is to do better on MAP tests, better on Kansas State assessments, and to get practice on multiple choice questions. And so as you go on to this next step, keep that in mind, okay? You're not just going to hopefully copy this down. I really want you to take the time. You're given the time to try and do these multiple choice questions to the best of your ability, just using a calculator. So go ahead. This is the first page of this little packet. You're going to tear this off and give this to the substitute. So once you check everything off, she's just going to put initials at the bottom, and then I'll know how your behavior was. Also make sure your name's on it, please, please, please. So you're going to turn this into the basket, the blue basket, and it's written on the table as well. And then these things you're going to leave in your workbook. So this is the assessment practice page. This is the first assignment that I'm going to give you, so you can kind of tear that off too. And then the second thing you're going to do is we're going to work on the graph of the week. All right, definitely watch the video for this because it's really impossible to see which of these lines up. But the first thing I want you to do is go through and practice these assessment questions. So it's 1, 2, 3, 4, 5, 6, 7, 8 questions. I will walk you through each of them step by step, but again, our goal is to get better at taking assessments. And then we are going to be putting this in your notebook. So I suggest you kind of go through and take it. Ultimately, we're going to fold it in half, and hopefully everybody has a 2-page spread next. So my bell work just ended on page 33. So I'm now going to be on page 34 and 35. You can add that to your table of contents. So 34 and 35. You can add that to your table of contents under, you can just say Valentine's sub-day. So it's going to be 2/14/2020, Valentine's sub-day. And I will know that this includes the graph of the week and the assessment practice. And then, what did I say, 34 and 35? That bell work was actually to page 33 as well. All right, so my idea is that you're going to do your assessment practice, check it with this video, and then you're going to be able to paste it on the left side. So you're going to write assessment practice number 2 on this, just like we did on the first one, but this is our second one. Assessment practice number 2. Sorry, it's kind of blurry. Anyway, and then you'll be able to glue that down. So go ahead and work your way through these problems. There are, like I said, I think 8 of them. And then I will go through and help you. So I'm going to try to get this focused, but go through, just make sure you show your work. You can use a calculator if you need to, and then I will go through all of the answers. So I went ahead and attached the left side so that I can close this, and it says assessment practice number 2. I used tape because I'm a cheater. I don't have a glue stick in my house. And then we're going to write assessment practice number 2 along the side. And let's work our way through these multiple choice questions. So you should have these answered now. Really, I want you to see, hey, was my thinking kind of along the right lines? Did I know what to do? Or did I completely forget this? I really tried to find questions that I think you should know how to do based on what we've done this year or based on things that you've seen previous years. So I'm going to go ahead and label these A, B, C, B, C, D, E, F, G, and H, just as a little reference, so that it's not like, what question is she on? So if you want to go ahead and do that, and then I'm going to start with question A. So Johnny jogged around the track 16 times. Each lap is 400 meters. Which process could determine the total distance he jogged? So here's how I would think about this problem, right? You have a track. Most of the time there's like a long side and then there's kind of rounded sides. And it is 400 meters all the way around. So the perimeter of the track is 400 meters. That means when he is going around it once, he's gone 400 meters, but he is going to continue going around that 16 times. So you could either add 400 up 16 times, or the fastest way to do that is just going to be take 400 and multiply it by 16. Okay, so 400 times 16 would give you the total amount of meters. You could do that if you wanted, but really all you have to look at is the operation going on. So if you add them, that's not really going to get you what you want. That's going to get you 416 meters, which is not nearly what's going on. You could divide 400 by 16, but that's also not going to give us the distance we want. The thing you want to do is multiply, like we said. If you had gone through any of those other ones, you would have realized that you would have gotten a pretty small number, and it seems from the problem that Johnny is doing a lot of jogging, not just a little bit. On B, what is the value of W in 0.8 W minus 7 halves equals 1 half? Okay, this is a linear equation that you need to solve, and I think it's probably going to freak you out just because of the fractions, but don't let that deter you. We are going to add 7 halves to both sides. If you had a calculator, you probably did this in the calculator, but that undoes the subtraction that's currently going on. So I'm going to have 0.8 W equals, and then because these have the same denominator, we can go ahead and add them up. So 1 half plus 7 halves gives me 8 halves. And if you put that in your calculator, that would simplify. So I'd get 0.8 W equals 4. 8 divided by 2 is 4 in the calculator. Then I'm going to divide both sides by 0.8. because that is what's being multiplied by W right now. So I'm going to get 4 divided by 0.8, and I just did it in my calculator, and it gave me 5 out. So W equals 5. B. Number C, another linear equation. What is the value of x in 3 times the quantity of x minus 4 equaling negative 21? Okay, we want to get rid of parentheses first, and I do that with distribution. So I get 3x minus 12 equals negative 21. And then it actually is a very similar problem to this. It just doesn't have the fractions and the decimals. So I'm going to add 12 to both sides. I get that 3x equals, you might want to do this in your calculator just if we're not super confident on negatives, but it's negative 21 and it's getting more positive. So that means it's going to be negative, let's see, 11, negative 8. Negative 9. Just kidding, negative 9. I'm like, that is not going to be a nice number. Again, happy snow day. And then divide both sides by 3. So x equals negative 3 is the answer. If you wanted, you could go back and plug that in as well, just to make sure. So you get negative 3 minus 4 is negative 7 times 3 is negative 21, and it'd be perfect. All right, D, what is the solution to the equation shown below? Very, very similar, okay? These are all linear equations. This is why I make you practice them so much on Bell Work, because all of these were from one test, so there was quite a bit. I'm going to subtract 5 from both sides, and I get that 2/3 x equals negative 4. Now you have two options. You can either divide the entire thing by 2/3 in your calculator, or if you're not doing that in your calculator, I would do this in 2 steps. I'd say, hey, 2/3 tells me multiplication by 2 and division by 3. So if you multiply both sides by 3, you're still going to have 2x equaling negative 12. And then if you divide both sides by 2, you get that x equals -6. And that's your solution. Okay, I make you do that so many times because you're gonna see that a lot. And then the last example, E, the only scary thing about this is there's variables on both sides, so that is something that we haven't seen in a while, but it definitely comes up. So what's the solution? You do want to get rid of the parentheses first by doing distribution, so you get that 5c plus 4 equals 2c minus 10. Don't write plus -10, it's redundant. It's easier just to write it as subtraction. Then you want to get all your numbers to one side, all your variables to the other side. So I'm going to put my variables on the left, my numbers on the right, okay? And that means I'm going to have to move the 4 over to the right and the 2c over to the left. Well, I like to move my variables first, so how do I move a positive 2c? I'm going to subtract it from both sides. I have 5c minus 2c, which gives me 3c plus 4 equals -10. Then I have to move the 4 to the other side so that I have all my numbers over here. Currently it's being added, so I'm going to subtract it from both sides. I get that 3c equals -14. And then I'm going to divide both sides by 3. So c equals -14 over 3. Okay? That is the answer as an improper fraction. It does not reduce because 14 is not divisible by 3. However, if you put that in your calculator, you notice that all of these answers are not equivalent to that. Here's the thing though. -14 thirds is definitely not -3. It's definitely not -2. And it's definitely not -1 third. And a lot of you guys can still convert to a mixed number. So 3 goes into 14 4 times. So you get 4, there's 2 left over, and it's 2/3. So -4 and 2/3 is going to be the answer on that one. I really don't like to give you mixed numbers much because you won't use mixed numbers after this year, but they are still free game on the test. All right. Question F. Allison is out to eat with her parents. She has an option of 5 different drinks: soda, coffee, tea, water, and juice, 2 main courses, chicken or steak, and 3 sides: rice, green beans, and potatoes. How many different combinations are possible? So this is something you did last year. You might have done it the year before as well, and we don't really do it a lot in Math 8. But here's how I like to do this, okay? Allison has 5 different options of things to drink. So what you can do is you can show this in a map, kind of a web. You're like, okay, to drink, she has 5 different options. After that, so she could have chosen any of those 5 options. She then has 2 main courses. So from there, she can have 2 different options on each of these. Okay. And then, so that was her, what was that? Her like main course. And then she has 3 sides that she can choose at the very end. So that 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Then it gets a little crazy. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It's on tape, so it doesn't really show. Okay, that looks nuts, but all you have to do to find your answer is count all the ends. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, that is a foolproof way to do that. Alternate option, which you're going to be like, that's so much easier, is to just take all the numbers and multiply them together. So you can do 5 different options times 2 different options times 3 different options. Anytime you're multiplying 3 numbers, multiply the first 2 first. So 5 times 2 is 10 times 3, which also gets you 30. Okay, I like the visual representation, but a lot of times with probability, there's a faster way to do it with multiplication, and that's how you would do it. 2 more. G. Oh, G. Let's see. It's really small. There we go. A school club has a t-shirt sale to raise money. After the sale, an inventory showed that 108 blue t-shirts and 96 green t-shirts had been sold. The sizes of these t-shirts included 60 small, 86 medium, and 58 large. Which table correctly represents this data? So here's where this is important, okay? You've got to figure out what the data is telling us. So the first row is all the blue t-shirts, and then the columns are the different sizes. The second row is all of the green, and then all of the different sizes. And so here's the thing. I know that 108 blue t-shirts were sold. So that means that this row right here has to add up to 108. Or it could be this row, or it could be this row, or it could be this row. Okay? And all you're going to do with your calculator is you're going to check, and you're going to say, hey, do those numbers add up to 108? If they never add up to 108, then you can eliminate that option. So for example, on the first one, I have 60 plus 86 plus 58. Oh my gosh, that does not add up to 108, so we're going to get rid of option A. Let me zoom out. On the second one, I have 34 plus 46 plus 28. Hey, that might be an option. The third one, I have 30 plus 43 plus 29. That adds up to 102, so that's not going to be a choice. And on the last one, I have 26 plus 40 plus 30. 96. And just like that, I found out that the answer is B. We can then verify that all of the other numbers work. So the green t-shirts have to add up to 96. So let's check that really quick. 26 plus 40 plus 30 equals 96. Hey. Then we can add up the number of smalls and make sure that it is 60. So 34 plus 26 is 60, and I'm very confident that B is the answer. And then the last one, okay? A cook has 2.5 cups of flour for each ounce of butter in a recipe. Which graph represents the relationship between the amount of flour and the amount of butter? So here's what I would do. I would make a table, and I would look at all of these and say, okay, do you see how butter is on my x-axis? So that means along the bottom, the x value is going to be the butter, and then the y value, or the output, is going to be the flour. And we can make a table for our first couple values. So if I have 1 cup of butter, it says 2.5 cups of flour for each cup of butter. So, or each ounce of butter. So if I have 1 ounce of butter, I have 2.5 cups of flour. If I have 2 ounces of butter, I have 5 cups of flour. If I have 3 ounces of butter, I have 7.5. And then all you gotta do is find the graph that has these points on it. So I need a point of 1, 2.5. So if I go over 1 up 2.5, hey, it's not on graph A. If I go up or over 1 up 2.5, it looks like it might be on graph B, but honestly, I think 2.5 is the y-intercept on that one. Okay, if I go right 1 up 2.5, oh, it's not on graph B. If I go right 1 up 2.5, oh, it looks like it might be right here on graph D. And then you want to check your next one. So if I go right 2 up 5, oh, it's on that one. And then right 3 up 7.5. Oh my gosh, so graph D is the answer. The reason why graph C is not the answer is because this tells me I have 0 2.5 and I need 1 2.5. If you were wondering about the y-intercept, it's going to be 0, 0, because if I have 0 cups of butter, I have 0 cups of flour. So having the origin and being a, hey, proportional relationship makes sense for that problem. Oh my goodness, there we are. Only took 20 minutes to get through these problems. I hope they make a little bit more sense, and now you're off to finish your graph of the week.